Yeah, yeah! 7 seconds of yeah. What's up, guys? It's Mwits. Alright, this is it. This is the original context of how algebra came about. It was written like how we explained in class the other time. It was written by Al-Khwarizmi. Alright, and the book is called Kitab Al-Jabr. Okay, and in turn it became Algebra. Okay, so now we're gonna look at how we can do some basic addition and subtraction of some algebraic expressions. Alright. Alright, before we go on, I need you guys to actually take note. In algebra, there are three types of numbers of which you will encounter. Okay, the first type is sometimes the number looks like this, sometimes the number looks like this, sometimes the number looks like this. Okay, so this would mean, let me change the color first. This is a variable. Alright, it's a variable. It's not okay, it's good to know what kind of number it is in the algebraic world. This is the coefficient. Okay. Okay, and this one is your numbers that you've been toying around for the past I don't know how many years. This one is called constant. Okay, in the algebraic world, so long as there's an alphabet here and there's no number beside it, it is a variable. If there's a number beside it, beside a alphabet, it's a coefficient, and if it's a number by itself, it's a constant. So these numbers, they are like a gang of their own. They can only talk to same gang, somewhat something like that. Alright, if I ask you 9 minus 1 is equal to 8. Okay, but if I ask you what is 9 minus x, okay, this is a constant. This is a variable. They somehow cannot we cannot derive we cannot make out a new answer to this. So this is the answer. Alright, similarly to this. Okay, okay, another example. What if you have x plus 2y? X is another type of alphabet, Y is another type of alphabet. Therefore, this is also the answer. See? Unless they're in the same gang, they want to expand the gang. Don't know what the gang. So when we have 3 students meet 4 more students. See? Same coefficient, same alphabet. They will become, guess what? 7 students. Okay. All of a sudden, 7 students, 2 want to leave the gang, so we remove 2, it becomes 5 students. So this is the basis of algebra. We need to identify the variables, coefficient, and constant. Constant, they can talk to each other. Alright. Similarly for variable and coefficients. Alright, variable, and as another example is x, one banana, we put one banana with another banana. It becomes x, and x, two entities, it will become 2x. Alright. Oh, okay, it's getting hot here. Alright, let's move on to application. Right now we have maybe some algebraic expression here. We have a 3a plus 2b plus 2a plus b. Okay, we take note that there's all of the symbols are positive. Okay, positive. Okay, sometimes in algebra, if a number or coefficient or constant appears in algebra without a symbol, naturally it will be a positive. Alright, and these guys are like cards. Okay, but I will show you one way, which is the vertical way. Okay, we have 3a. We identify the alphabets. We have a here, we have a here. Okay, we have b here, we have b here. So we can rewrite everything down so that we can add or subtract the values. Okay, so we put 3a and maybe 2b from here. I put here. Now this a and a, they're the same, so I can put 2a here, and from here this b goes to here. Since the symbol here is positive, plus, so I put plus here. Okay, so it's actually a plus. It will give us, so same alphabet, they can actually handle each other. So 5 apples and 2 apples, they become, 3 apples and 2 apples becomes 5 apples. Alright, 2 bananas plus 1 banana become 3 bananas. Alright, this is the vertical method. Okay, what about the other method? The other method, we arrange them like cards. Like I mentioned just now, we can actually form them into cards. So let me take another color. Okay, but in order to form a card, the algebraic value, the expression must have a symbol in front. For example, like plus, and then algebraic expression. Okay, this can make up a card. A card must have a symbol and the algebraic expression here. So let's take a look at the above equation. Let's turn them into cards. Okay, we need a symbol at the front, and we need a algebraic expression here. We need a coefficient here. We put a symbol at the front. Okay, this will make it into a card. Plus 2b, same goes for this, plus 3a. So these are cards. So ultimately we're gonna shift places. So this a here and this a here, ideally it will be good that we place them just beside each other. So what I'm going to do right now is I'm going to actually select this 2b. I'm gonna move it here. Yeah, it's like cards. Once again, I'm gonna take this 2a. I want to ideally move it beside this 2a. Okay, I can move it anywhere. I'm going to move it here. Alright, I'm going to make space for this guy here. I'm going to put it here. Okay, wait a sec. I think I'll make it a bit. Yeah. So once again, there I have it. Now it looks much more clearer this way. You see, 3a plus 2a. I can actually settle stuff here. Alright. This 3a and 2a, positive and positive, they will plus each other, it becomes 5a. Alright, positive 2b and b, 2 bananas plus 1 banana is 3 bananas. Okay, there's a positive sign here, so it's positive. So this is your answer. You cannot derive any, you cannot simplify the expression anymore. So this, and ideally we'll write it closer. 5a plus 3b. Okay, so okay, let's do some practice, and then yeah, we'll see how things goes. I gotta go.